Hi, I'm Chris DeLeon of Game Keto. What follows is the opening talk that I've been giving for every semester for years for a number of organizations. It was originally developed for VGDev, the second student club I helped start, but I've done this via Skype now for many other clubs around the nation. And I'm hoping that by having it in video form, you can share it with whatever your organization might be, wherever it might be in the world. VGDev has made about 45 games in the past 4 years by following the process that we're talking about here. And I built that pattern off of a club that we established 10 years ago, Game Creation Society at Carnegie Mellon. That's now produced over 100 games in that time. Now, I don't want to create the impression that there's only one way to do things. All I can speak to is our experiences, our patterns, our approaches. May or may not work for where you're at. Feel free to adapt it. Things are always changing. But what I can say is that this has resulted in a lot of games and helping hundreds of people get into game development. The first thing I like to point out is to make it important to not identify with struggling. You don't want to identify with taking on more than you can handle. And sometimes people have a tendency to want to immediately shoot for the moon, and then they start to sort of just get themselves into this mentality of that's what game development's all about. It's not. Game development is about developing games. Most projects at our scale fail because they try to bite off more than they can chew. And this is even more true for multi-month projects than it is for game jams because the deadline seems so far away, because it seems like you have so much time. And especially if it's your first time working with a team, then you think, aha, I've got 4 or 5 people, I can do 4 or 5 times as much. It's simply the wrong way to go about thinking about it. At the start, biting off more than they can chew means that they're trying to do too much. But in the middle, means that they're just letting feature creep set in and they're trying to do even more. By the end of the project, it's an unwillingness to cut their scope to do a little bit less in the name of getting the game done by the originally promised deadline, which is really important. It's better to do something modest very well than to do something impressive poorly. An example I've often liked to hold up is to say, if one person says they're building a canoe in their garage, you can believe them. They might be building a canoe. It might be a pretty decent canoe. If somebody says they're building an aircraft carrier, at best, they're going to have a huge pile of scrap metal. They're probably not building something that floats. And only one of those two people is going to make something that actually serves the function it's trying to make. If you build pieces and parts of a massive game, that's not a game. You got better to do a polished and excellent job of something small. And sometimes people look at the kind of games that have come out of these clubs and ask why so many of them tend to be gamey or arcade style. Some people like to turn the question around and phrase it, Chris DeLeon, why do you hate narrative, adventure, and fun? Well, it's kind of harsh. Of course, the reality is that arcade or retro content is a lot less demanding than more modern console or PC retail. And I mean modern even in the sense of the past decade or two. So here we see on one side, Joust. It's an old arcade game back from the early 80s by Midway. And it's only got a handful of types of animated characters in it. That has different colored variations of it. All the levels are a difference of tuning in terms of how many platforms appear, in terms of how the birds behave, what ratio of different difficulty birds appear. And compare that to a game like Zelda, which I show here the Super Nintendo version, but its older and newer equivalents have a similar issue. It's a huge world of hand laid out environments. It has a ton of bosses that all have special programming behaviors to them. It has a ton of content to balance and a ton of functionality through power-ups to deal with. So naturally, it's not just about pixel graphics being easier to draw. There's design things that we have to think about as well in deciding what types of games we build. And it's not really about being anti-story, but it is to say that when you see a game like Heavy Rain or whatever that has a lot of narrative focus, they can achieve cinematic style plot. But you can still have story in your game. You still have meaningful narrative in your game, just in a different sense. And so we see here some examples from VGDev, one of which is based around sort of the nature of the world and how the power-ups interrelate. So there's a fire world and a lava world and an earth world. And those powers are kind of the story because they're the situation, they're the setting. You'll see in these other bubbles, it can focus on atmosphere. It can focus on a time in history. Or it can focus on a place in the world without having to be a literal, he said, she said progression of events with cutscenes and all that mess. Where I'm getting at with all this is that how much work that you have to do is completely in your control. It's completely up to you as a project leader, as members of the team. So it's not like a situation in a workforce where someone's going to say, get X done, and you say, we don't have enough time to do it, we have to extend our deadline. At any time you can rethink, you can reevaluate what the task is that you're working on, or if you're someone on the team who's just a contributor, you can always push back and say, well, I can't get that done in this amount of time, but here's what we can do. Genre choice plays into this. One reason why a lot of historical games involved vehicles, whether tanks or helicopters, planes or cars, is because vehicle games, giving the right perspective, is a lot of rotation and translation of the graphics, even in 3D space, as opposed to the human body animated, or any animal body animated, which can be extremely challenging to do well. One of my projects many years ago, Alice in Bomberland, we had a great talented professional animator involved with it, making our main little Alice for the game. And he spent the entire length of the project perfecting that animated character sprite, during which we finished all the other power-ups, all the other content, all the other sprites, all the other backgrounds, all the other writing. Animated characters tie up a lot of time, so be careful and get your most bang for your buck out of your animated characters. A lot of that sliding and translation also applies to games that are puzzles. And puzzle games are still a valid genre, of course. They're still something people enjoy playing. You can't dismiss them. The other thing to think about is how can you exploit an empty space or an open space? So we see here Battleship 88, which took place in the open ocean. That meant that not only did we have no graphics to deal with like land, coasts, and so on, but it also meant we completely avoided any navigation or AI problems of trying to get a ship from point A to point B without looking dumb driving into land. The same thing happens in space, whether you're in overhead or 3D space. Same thing happens in a snow-plowed field. As long as it's mostly smooth or the trees are thin enough, you expect to move through them. Same thing can also happen in an open sky full of clouds. Now, my pacing guideline as to how quickly people should bite off more and more is that for each middle-sized main kind of project you develop, make maybe a 5 or 10 year jump in history. And so I've got kind of set up here from one side to the other. We've got Space Invaders and Asteroids, Pac-Man and Frogger, Rampage, old Mario Brothers. We've got F-Zero and Bomberman. But it's a progression of complexity which allows you to focus specifically on the foundations each layer of the way. So your old games from kind of late 70s will make you just deal with how to get a graphic on the screen, how to get sounds to play, how to get collisions to cause effects. And they'll allow you to focus on doing those things well as opposed to spreading yourself too thin, trying to learn too much at once. You then have that as a foundation as you begin to move forward into the 80s, when levels involve more structured data, when that's a part of the game as to how you interact with things like the buildings in Rampage, things like the puzzle in different types of games. And that's something that it's good to be not worrying about that until you've already solved the kind of issues like how to keep score, how to have menus, how to restart the game as you would in an older style of game. And it's important, by the way, when I make this point, I'm not talking about straight up cloning these games. You don't need to make an exact clone of it, but I will say, don't trust your memory or video on the internet about how these games work. Go out of your way, find a way to emulate or play them, and you're going to realize there's a lot of attention to detail in what makes that game work. Any one of these games, when it came out, there were a lot of other games that looked maybe kind of like it that did not define the game industry's history in the same way that some of the more popular games did. Here showing Tempest, Defender, Robotron, Donkey Kong, and Galaxian. It's better to get to your core playable gameplay within days. So you could think of it, even if you've done game jams before, as the game jam can be how you start your project. Thereafter, you're polishing for months. This is the same strategy that's been applied to great success by Vlambeer, the duo shown here, to achieve all kinds of best-selling, best-reaching, famous indie games from Super Crate Box to Radical Fishing. Get your game or Luftrausers as well. Get your game playable as soon as you can, get the core playable, and then you're not done, you've just started. Even mid-1980s arcade, by the way, can be very hard, showing here Paperboy or Rampage, in terms of the sheer quantity of content expected for these kind of environments, as well as the complexity of data structures. These are non-trivial, these aren't the default things that a computer naturally isn't built to do. By the late 1980s or early 90s, you started to see many content-driven games, showing here Simpsons, X-Men, and Ninja Turtles. These are games where they largely play very similar ways in terms of the gameplay, but the main difference is how all the animated characters look and how all the backgrounds look in these really long levels. This is a dangerous space to take on if you don't have a large team of experienced artists and animators to work with. We've seen one or two beat-em-ups built out of these organizations, but they tend to be very, very, very slim on content, and at best, a kind of proof of concept for what the game might have been like, starting to stretch yourself thin even by just a couple decades into game history. And some genres have unfortunately always been content heavy. There's simply no way around the expectation of having hundreds of kinds of enemies in a classic RPG system, or dozens of kinds of armor and items and magic spells. Those conventions are deeply entrenched, and it's very hard to pull these games off well in a limited amount of time, even if you go old-fashioned on them. Now, I want to make a comment about art games, because one of the ways that people have tried to solve the problem is being resourceful, but still making things that are very novel and very unusual. And this process tends to involve building things that you haven't seen before by iteratively going through and sort of thinking at a high-level concept from the beginning, but then letting the game kind of develop itself as you go. And I've worked on art games. I think they're valuable. Some of them are very personal. I've worked on a lot of little experimental games, but I think that these are not necessarily the best thing to be involved with game development clubs. Because something you have to think about is, in the same way that experimental games have only a limited reach and appeal because people don't know ahead of time what to expect from the game, that same thing can make it much harder to appeal to other developers to join your project. It can be very personal. It can be very hard to tell where it's going until you've finished it. So I, by all means, encourage and make and explore art games, experimental gameplay, but maybe that's better for sort of a game jam setting or a solo project, as opposed to the kind of team you get where people want to build things they recognize, where they can know up front, oh, okay, I know what the conventions are for that genre, let's go and do a good job of it. Every single step of the way, you're going to have to be cutting things. And you want your game to still survive. You want it to still come out in a playable way. Now, if you do it right, most people will have no idea what you cut because you've removed any evidence that it was there. So we've had an example of a game that had a level select screen, but only one level in the final game. Well, we just removed the level select screen. We've had games that had a menu for inventory. Only one object that was always in your inventory. By the time the game's done, remove that inventory and the evidence is gone. So when you're thinking about your game, you got to plan to expect to cut off entire modules of it as you feel them out, as you develop them. And that's not failing. That's just how games get made at every scale, whether it's a game jam, whether it's a multi-month, semester-long project in a club. Professional projects see and do the exact same thing. Editing only makes games better as you go. It helps focus them on what's working. I also want to clarify, when I talk about doing these kind of old-fashioned things, art style doesn't necessarily need to limit itself in the same way that code and design should be paced by the person who's maybe leading the project or doing the implementation. Just because you want to make a game that plays like an old game like Combat or Tank doesn't mean you have to build games at this resolution. If your artist wants to go nuts and make it all in 3D high poly models, they're welcome to do so. Part of what's great about old games like this is that there's so few distinct elements in the world that you could focus on doing a great job of all of them and not be stretching yourself too thin like you were trying to make tile sets for dozens and dozens of types of worlds in a larger open world environment. For programmers out there, I like to emphasize the importance of using modern programming libraries and development tools. For my first decade making video games, I made the mistake of digging through the back of books to find assembly routines, to change resolutions and plot pixels. I had entire books on loading image formats in C. That's not the way things get done anymore. Find yourself a good library that allows you to focus not on how do I load a PNG or how do I play a sound effect, but instead let you worry about, okay, where do I want to position that PNG on screen? When and why do I want to play that sound effect? So you can then focus on what your game does differently instead of reinventing the wheel that many smart people have come before us and come up with a lot of good solutions for how to do those things. Any game library is generally way better than using none. Now, if you're an extremely experienced programmer and you've been making games a while, you may have broken the mold on this and either made your own personal library or made games without them. In that case, you know who you are, you know this doesn't apply to you. For everybody else out there, I really, really encourage you to look into things like SDL, Monogame, Flixel, SFML, Phaser, or any of the millions of other libraries out there for ActionScript 3, for HTML5, for C++. The language alone is just a starting point, but if you want to focus on what your game does, then you want a library that's going to help you manage your inputs, manage your files, manage your images, manage your sounds, and so on. Burden's Donkey is a parable that I like to present here because it relates to the picking of a library. A lot of people get bound up because they feel like they have to find the perfect library. They need to find the one that's just right for what their game does and is. And the reality is that paralysis is setting them way back, way back, in a way that if they just picked one and ran with it, they'd learn a lot in the process. The only wrong choice is to pick neither. Burden's Donkey is a parable from philosophy in which, see here a political cartoon from the early 1900s, a donkey can't decide between two equally appetizing bales of hay, and so, lacking a reason to eat one or the other first, starves to death with twice as much food in front of it as it needs. It has no reason to really starve, but it does because it can't just pick one and go with it. And that'll happen when you pick your programming environment, that'll happen when you pick your libraries, that'll happen at every single point of making video games. We're going to have more ways to do things than you actually have time to fit in or than you can evaluate. Don't get stuck on it, pick one and go with it. You can always learn more later, you can always change things later. It's never been easier or better to make games. Don't let that be an excuse to be paralyzed at the number of options. All of the options are pretty darn good. Except to say, and I do like to use this as a qualifier, even though I talk about using libraries and other things, a AAA game engine, the kind of stuff you see in many commercial games like say Far Cry 3, having access to that does not shrink your workload. We see here Allegro, it's a game built in a library, or Alex the Alligator built in Allegro library, and it's a great fun game. You can see it's intentionally mimicking sort of Game Boy aesthetics, so it could achieve a certain quantity of art and a consistent art style. On the other side, we see Far Cry 3. And what happens if you pick up an engine like Far Cry 3 is you begin to think, oh, they've already done so much work for us that we have a better starting point. But the reality, of course, is that you have completely changed the scale of expectation of what you're doing. It'd be like if you and your friends had industrial construction equipment. Would you know what to do with it? Or would you tear up some dirt, dig a hole, stick some steel together, and call it a day? You could probably much better achieve a really, really great looking Lego building. And that's closer to the kind of things that we can do at a small scale successfully, as opposed to putting ourselves in the same competitive league with companies that have hundreds of employees and 6 years of full-time paid experienced developers. You're entering a much tougher turf. Even if you're getting a head start there, I encourage many folks to explore first, not using those kind of game engines. Now there's an exception. There's actually a few exceptions. Some engines are extremely indie friendly. These can't be ignored, they shouldn't be disregarded. GameMaker, a lot of people have done good stuff with it. In our game clubs, we've only had a few projects that I've seen made with GameMaker, but I've seen a lot of indies also, really successful indies, who started with GameMaker and then moved out of that space, or found ways to do really clever things with GameMaker that no one would think that's from GameMaker. Unity has really absolutely blown up and taken off in this kind of scene for all kinds of advantages I'll be talking about in just a minute. In Unreal 4, so Unreal 3 fell in that category of engines that were a tough choice for an independent game team. It was great for a huge professional team. It was a lot to manage for a small team or solo project. Unreal 4 has some advantages over that do make it probably a little better suited for an independent game team for students, but it's a bit early to tell yet how it's going to shake out. I'm hopeful it's going to compete with Unity as being another great choice for small teams. But be on the lookout for it, learn it, think about it, but I can't exactly recommend it just yet. I've seen dozens of projects come out of Unity. I've yet to see any student projects or semester team club projects come out of Unreal 4 yet. When you're picking a programming language or tool, you want to look for one of three things, or at least two of, 3 of 3 would be great. You're looking for, is it high performance? And this tends to be your C family or C++. You might use it with SFML or SDL. C++ alone is just a programming language. Those libraries, again, let you do the game stuff with it. Or Unity also is surprisingly high performance for the level of simplicity it provides and the level of built-in support it already has. You're looking for something that's easy to distribute. If your game's hard to share with others, it doesn't matter how great your game is unless you just want it to exist as a YouTube video. Web playable is really desirable. At this point, it's really hard to get someone to download, install, run your game, and then uninstall it, not the least of which many people out there don't have their system configured to run or to download rare zip files or to run executables that aren't authorized from a particular distributor. So consequently, web playable is great because now, instead of having to fight to get dozens of people to download and try your game, you can put it up on a place like Kongregate or Newgrounds, get hundreds, sometimes thousands, sometimes hundreds of thousands of players to try your game by going to a URL, playing it, and then moving on with their life and forgetting about it. It's an amazing capability. That said, Unity can also export a game to the web in a way that makes it trivial to distribute. The third option is to make sure that it's very fast to develop with. These are the sort of things you often would see in game jams or rapid prototyping environments. GameMaker has this going for it. Love2D and Lua are great for this kind of choice. Unity, using a particular approach and way, a certain set of methods, can also be used to rapid prototype. So naturally, you can see why Unity has increasingly picked up and kind of overwhelmed the use in these kind of clubs. Now, the wrong reason to pick a language or tool is because it's the one that you already know. That's awful. The differences between one library, one programming language, one platform, and another are often a lot less than you might think. You're not starting from scratch. It's not like you're going from learning to speak Japanese to speaking Greek. The programming languages are mostly differences in semantics and one or two key features for you to learn how to use. So I recommend, if the language you've got doesn't fit these criteria, if the one you have learned already for classes or any other reason isn't high performance, trivial to distribute, very fast to develop with, prepare yourself, take a few weeks, learn something else. You'll be really glad you did because your game is going to work better, your game is going to reach more players, your game is going to be a lot easier, and your game is going to benefit from the faster iteration from your ease of development. Now, when thinking about the programmers to go on a team, I want to point out that a smaller team of coders has some big advantages. One of the mistakes teams will make sometimes when they're new is thinking like the more programmers they get, the more they can do or the faster they can do it. It's backwards, not how it works. And this insight comes actually from Frederick Brooks's The Mythical Man Month. It's a book I recommend for anyone out there interested in software engineering to pick up. It goes back to an old IBM project where they thought of building code like building a building. In which case, okay, if you're behind schedule in a construction project, you just double the construction workers, you get done in half the time. In code, that doesn't work like that way because of the abstract complexity of what's going on, because of the myriad of different ways things can be done. You actually raise a lot of communication complications. Gone is the ability just to write something that works and move on from it and connect it to something else. You have to have a lot more planning, a lot more architecting, a lot more communication and commenting to make sure that nothing falls between the cracks, to make sure people aren't stepping on each other's toes. Before long, you have to have additional layers of management just to help coordinate the programmers, and a bunch of their time winds up being reading each other's code to make sense of it instead of making things work. And I've seen many cases where a single programmer could hack and get things done and delivered a lot faster than a bigger team of individuals. Now, if you're going to work for a company, obviously you got to learn to work with more people because you're going to have to build bigger systems. But for these kind of games, even a multi-month project, 1 or 2 programmers is often an advantage versus trying to cram in 4 or 5 into the same project. Now, as a design constraint, I encourage people to consider what's the minimum for a demo, light, or shareware version. And the reason for that is because your game is really functioning as a proof of concept, for one. If it's great, your team can then make a sequel. Your team can go do something else with it. 2 is because that minimization of the number of levels or the number of fighters or the number of power-ups or whatever will give you a lot more flexibility to make changes throughout your development. As you make things, you're going to come to new realizations about what's working and what isn't. And the more of anything you have, the more you're multiplying the amount of time and energy it's going to take to fix or add things to your design about it. You have to think in terms of trade-offs during these projects. This is an old John Carmack quote, big fan of Carmack. Of course, id Software, Doom, Quake, anymore, Oculus. If you're willing to restrict the flexibility of your approach, you can almost always do something better. Of course, he's speaking to the fact that you shouldn't be trying to do everything or make a game engine that supports everything. At that point, you're trying to rebuild Unity. And let me tell you, those folks have a head start on you. You're trying to rebuild Unreal. Again, they have a head start on you. Don't try to build an engine, build a game. Build something that does exactly what you need it to do and does it well. And you're going to be able to find that as long as you accept the things that it can't do and your approaches that you pick, you're going to get a lot more done. You're going to make a game that's a lot more impressive with the same amount of time, same amount of people, same amount of work. And when you pick up anything you want to do, you got to think about what's this going to cost me and other things that I'm doing on my project. No one's going to read a 25-page design document. I've seen a lot of people who try to join these situations. Their first instinct is to fill a notebook with things about their game. Nobody looks at that stuff. Even the person who wrote it won't. And the worst thing, too, is how much less flexible it makes your project as it develops, because it's someone's then full-time work to go back and keep that document updated, or it becomes even more useless. What I suggest instead is having a screenshot mock-up. Open up Photoshop, open up Gantt, use Paint.net, whatever works for you, and draw per pixel, or at least in per proportion, what's on the screen during the game. So here we see Saturn Storm on the left. That's the mock-up screenshot. On the right is how the game wound up. And what's great about this is it puts in a single place answers to a lot of concrete questions that would be hard to interpret out of prose written documentation. Okay, is there a score on the screen? Is there an ammo limit? You can see here wind and turbulence indicators. Tells you something about how this bombing game works. How big is the character on the screen? What's the structure of the level like? Is it on a grid system? Is it dynamic? Is it isometric? Where's the camera positioned? All this gets answered instantly in a concept, like a mock-up screenshot of how the game should look when it's being played. Now additionally, you'll see that the final screenshot actually reused the same platform graphic recovered. Everything else there is replaced and new, but that's because the first thing that I did to make this game work was I then basically brought that screenshot to life. I tore those layers apart from the image itself, used that as placeholder art while I first got the plane to control and then the level to work and then the platform to work. And as we moved forward, we figured out that that platform placeholder was good enough for us to keep, so we did. Meanwhile, we replaced and rethought a lot of other things about the game, but it got everyone on the same page immediately without having ever played a game exactly like this to know, okay, what is the vision we're driving towards? And if someone didn't like that, they wouldn't join the project, and that's fine. It's actually better if someone's not on board for the same vision. What you don't want is someone to be imagining your game completely different than what anyone else on the team is thinking about. Those things are hard to unravel and hard to remedy later on. We see the same thing here for Eternal Storm. That was the sequel to that game, built in isometric. Want to kind of show what about the gameplay is different? Mock-up screenshot on the left, one of the final levels on the right. Now there's other levels in Eternal Storm that look very different than that, but we did once again find ways to reuse the same core elements, the same graphical pieces from that prototype art to use in the game itself. Battleship 88, another game from Game Creation side, we use this method with, on the one side, screenshot mock-up on the left, final game on the right. And it spells out, again, in a way that everyone can immediately see and pick up, okay, there's a radar, there's ships on the screen, they're floating around in the open ocean, there's a throttle indicator, the ship can take damage in different parts of it, that's core to the game's functionality, and there's a thing with some little plane stamps on it. You can ask questions about what that's for. Now, there's things you can't understand from looking at this, like the fact that your ship has both anti-aircraft guns and cannons, and that's why in addition to that mock-up screenshot, you can still have a design doc, but it's really a design page. So this is the entire design documentation for that Battleship game. It's one page front and back. We have the storyline, which is super campy because it's kind of supposed to just be old, simple stuff. We didn't have a long time frame. This one we picked up mid-semester as a triage project from something that wasn't working out. We have a list of features. What are the core things to this game that make it work that you can't tell from looking at the mock-up screenshot? Then we have a list of the art needs, just high-level groupings. Okay, we need some planes, need a few ships, need an aircraft carrier. What's the minimum art we can do for this game? It's always easier to build off a minimum than it is to regress from what you wish you had. And then sound effects needed. Now this is an unusually long, detailed list of sound effects, but we knew going into this project that we actually had a great team of sound effects experienced people remotely working with us who wanted specifically to exercise their skills in doing sound effects. When you're designing these projects, you often want to account for what are the strengths of people who are on my team, what are their interests, how can I design the game in a way that gives them a chance to practice what they want to do. Your game's going to come out better for it, they're going to be happier. Their reward at the end of the day is also that they got their credit on something that they can be proud of because it let them shine at what they do. And then lastly, I have a week-by-week schedule of what we did in the remaining 5-6 weeks of that game's time to wrap it up in terms of what had to happen each week to get this game playable and deliverable. Now this game, this Battleship one, was actually the most popular project I ever worked on before I started doing web games. It was especially successful in Brazil and Czech Republic for reasons that I have yet to figure out, but that's what the web analytics seem to say. For scheduling projects, what we see here in the middle is Excel. This is something that I did for Eternal Storm, and this is simply a matter of every single row is one day of the week. Pick a day. If you have a group meeting, make it that day. But it's, Thursday followed by Thursday followed by Thursday. And so that's the weeks going down from start of the project all the way to finish. And then along the top, we have each of the roles. And this isn't by people, this is by roles, because on a small team, one person might be doing multiple columns of work. Or if you have multiple people who are, say, great animators or great sound effects people or whatever it might be, you might have multiple people sharing a column, but you don't necessarily know who the people are because they'll come and go throughout the project. And so then you can lay out in those roles what has to happen per week for this to move forward. And I find this is a great way to visualize who has downtime which weeks, how and when are we going to do things that will unblock others on the team, and what are we falling behind on. Trello, more recently, is a great way for doing this. That's Trello, like you see there. It's just a team management system online where you can all assign tasks to each other. You can shift them from the to-do list to the active to the completed list. It's really great. I've seen a lot of projects using it and benefiting from it. That said, I do want to stress that while these project management tools and approaches are helpful for getting an idea of what's going on and what's falling through the cracks, it's still important to meet with your team in person if you can, or at least to chat live as a group through Skype or through Google Plus or anything else you can, because there's so many things you can't tell through emails. There's so many things you can't tell if it's just you distributing tasks about what's working, what's not, who's overwhelmed, who needs support, who's working well together and might benefit from working even more closely together. Those are things that are going to come out of actually getting together in person at least once a week if you can. Your project and your people are all going to benefit from it. One of the final points I'd like to talk about in closing is this idea that a Lamborghini is not a polished clunker. We see a lot of people who they'll make one of their first bigger projects, one of their first times they have either a bigger team or a bigger time frame, and it comes out in a way that they know is rough. They know it is, and they're frustrated because they have good taste in games, and that's, of course, why they're involved. To use the old Ira Glass story about this stuff, he says that when you first make things, anyone who gets into things, it's because you love them, it's because you have taste in it, and you're frustrated with yourself. You know you're not doing stuff that you know is good, but the mistake is to think, and this is me, not the Ira Glass stuff, the mistake is to think you can keep polishing on it, keep iterating on it, and it's going to somehow magically turn it around. Often the major issues were very foundational, very fundamental, or they're so deeply ingrained across the project that no amount of little iterative fixing is going to make it from being a decent or even a only okay game to a great one. So even though polish is important, even though polish is what the kind of organization is all about, doing it on a longer term project, at some point you have to accept that maybe the game is as good as it's going to get. If you keep working on it, you're just going to get diminishing returns where your work stops paying off. I've even seen negative returns, worse than diminishing, where the project got worse the more time people tried to put into it because they started questioning even the things that were working about it. Sometimes the game turns out great, sometimes it doesn't. You can't always tell until it's too late in the cycle to really do anything about it. And so what I recommend in those cases, wrap it up, finish it, don't abandon it, finish it, tie up whatever else you can. Make a list of what's left to do and only let that list get shorter. Scratching things off that you decide aren't needed, or scratching things off as you do them, but don't do anything that's going to make the list longer. Get it done, get it out there. It's going to be practice delivering your game. Everyone in the process benefits from that because then they're free to move on to the next projects. And that's really important because often the contributors to the project, maybe even the lead, didn't do anything wrong that made the game not great, but they're meanwhile all getting experience that they can carry on as lessons and skills to the next game where they have a fresh start. So once again, it's Chris DeLeon here from GameKeedo. Hopefully it's been helpful to you. If you have any questions at all, reach out to me at any time through GameKeedo, GAMKEDO @gmail.com. Love to answer questions, love to help support more clubs getting started. Thank you so much for your time today, and I wish you all the best of luck with your projects. Thank you. Bye-bye.